Good morning, everyone. Welcome to the tutorial on PAMI, an open source library for finding interesting patterns in big data. I am Raghav Uday Kiran, working as an associate professor at the University of Aizu, Japan. My research topics include data mining, intelligent transportation systems, and deep learning. More information about my research activities and my lab can be found at udayrage.com. The outline of my presentation is as follows. In the first session of this tutorial, I will be covering the learning algorithms, followed by the available packages and the importance of pattern mining. In the second part of my tutorial, I will be talking about our software, that is PAMI. In the third part of this tutorial, I will talk about different types of databases and how to create them. We will also discuss how data frames can be converted into different types of databases using PAMI library. In part 4, we will discuss how to generate or how to extract the statistics of a database. Then we discuss how to implement different types of algorithms. And then we discuss how PAMI can be integrated along with other machine learning libraries for knowledge discovery purposes. Let's go to part 1. So when we talk about learning algorithms can be broadly classified into two types. One is learning from the logic or rules. So in this class of learning algorithms, users provide their domain knowledge in the form of logic or rules. The algorithms learn from these rules and make decisions accordingly for a particular task. The classic example is block placement. For example, if you want the block B to be placed over a block A, what kind of operations has to be done to achieve this objective comes under this class of learning algorithms. The next class of learning algorithms are learning from data. So these algorithms learn from the data and complete the assigned tasks. So these algorithms can be classified into three types: unsupervised learning, semi-supervised learning, and supervised learning. So in unsupervised learning, user will not provide any information about the data. The user simply provides the data to a learning algorithm, and he tries to get interesting information hidden in the data. In supervised learning, user provides additional data explaining the given data set. The learning algorithms makes use of data and additional or metadata and use it for decision-making purposes. In semi-supervised learning, user will provide some information on some portion of the data, not on the entire data, but on some portion of the data. Okay, and the rest of the data will remain unlabeled. The algorithm has to learn from this type of data, okay, data set and has to make the decision. This is called semi-supervised learning. And then when we look at the algorithms, these algorithms can be broadly classified into 4 tasks. Knowledge discovery algorithms can be broadly classified into 4 tasks. One is pattern mining, next one is clustering, then classification and prediction. We have 4 classes. In pattern mining, okay, the user will simply give the data set and ask the learning algorithm to extract the hidden patterns from the data. For example, I will give the sales data of the customers. And then I say, find some of the hidden patterns in the sales data. The learning algorithm will evaluate that data set and says and discovers useful knowledge. For example, it can give us the information that people who have purchased bread have also purchased jam. Such kind of patterns can be extracted using unsupervised technique. The next one is clustering. In the clustering, the user will simply provide the dataset. For example, the user can provide the crimes in different places and he simply asks the learning algorithm to group them based on the similarity of the crime rates. The learning algorithm, what it will do is, it will analyze the data and group the data into clusters so that the elements within the cluster are highly similar as compared against the elements that are in other clusters. So this is called clustering, in unsupervised learning. In the classification, users will provide some metadata, which can also be called as labeled data. Okay, so here I have taken the details of the customer and I have given the metadata, that is whether a customer will purchase the computer or not. Depending on the purchase history, the customers will say, okay, but will be labeled as yes and no. The learning algorithm will analyze this labeled data and makes a model. Next, when the users ask, okay, now guess for a new customer whether he will purchase a computer or not, the algorithm makes the prediction of it. Same thing. Prediction also same thing. So given the past data, the learning algorithm will learn from the past data and makes the future predictions. So these are the different types of learning algorithms that are available to us. Now let us look at the available open source libraries. When we look at the available Python libraries, we have sklearn, TensorFlow, PyTorch, Orange, etc. to perform classification, clustering, and prediction. However, we don't have any library for pattern mining. This motivated us to develop an open source Python library dedicated to pattern mining alone. So how do we do this? That we will be covering in the subsequent slides. However, before talking about our software for pattern mining, we would like to provide the readers or the list audience with what is pattern mining. So let us look at the pattern mining. To explain pattern mining, we have divided the slide into two parts. The left side of the slide will give you the mathematical model. The right side of this slide will give the example so that the audience can easily understand what is a frequent pattern model. Assume we have some items I1 to IN. In this case, we have items from A to H. A set of items is called an item set or a pattern. So for example, AB is a pattern. Similarly, A, B, C, D, E, F is also a pattern. So all of them are patterns. Then a transaction T is a pair of transactional identifier and a pattern. And when we say a transactional database, it is basically a collection of transactions. So in this transactional database, we have 20 transactions. Each transaction has a unique identifier. Please note that the items within a transaction can reappear. For example, TID1 has AB items. TID10 also has AB items, and so on. Next, once we know the pattern, we simply measure its frequency. That is, number of times a pattern has appeared in the database. So frequency of AB here is 8 times. It means in the entire database, the pattern AB has appeared 8 times. Now, when we have the frequency, we calculate its support. Support is nothing but the normalization of frequency using the database size. So support of AB equal to the frequency of AB by the database size, that is 8 by 20. So 40%. It means the pattern AB has occurred in 40% of the transactions. Now we say that a pattern is frequent if its support is greater than or equivalent to user specified minimum support value. For example, if the min support value is 35%, then we simply say AB is a frequent pattern because its support of 40% is more than the user specified 35% threshold value. Now, looking at the problem definition, it is very simple. Given a transactional database, our objective is find all frequent patterns that satisfy the user specified minimum support threshold value. So this is the simple problem definition of a frequent pattern mining. So to solve this problem, that is to find all frequent patterns in the database, we have to understand an important component called search space. So what is the search space for a pattern mining model? So to explain it, we use the following example. Assume we have 4 items, A, B, C, D. The items at lattice of this search space, okay, the items at lattice of these 4 items represents the search space. So the size of the search space is 2 power n minus 1. So in this case, it is 2 power 4 minus 1. So that is the item set lattice or the search space for frequent pattern mining. This search space, that is 2 power n minus 1, is very, very large because, you know, in real world, there are thousands of items. So in this case, our search space is going to be very, very, very huge. So how do we reduce the search space to make the pattern mining practicable? That is the challenge. To make pattern mining practicable, we use one important property for reducing the search space. That property is called a priori property or anti-monotonic property or downward closure property. Please note that in the literature, people use these three terms interchangeably. So please keep that in mind. So what this a priori property says is, if a pattern is frequent, all of its subsets, non-empty subsets in particular, are also frequent patterns. For example, if I say the support of AB is greater than or equivalent to minimum support, then it means support of A is also greater than minimum support and support of B is also greater than minimum support. This is the property. So how do we use it? Assume this is our search space. Now, if we start from item A and if we go down and we notice that AB is infrequent, that is support of AB fails to satisfy the min support value, we simply say AB as an infrequent pattern and all the supersets of AB will also be treated as infrequent patterns and we don't go to the mining of this. So this approach of using downward closure property for pattern mining facilitates us to achieve practical real world, to handle practical real world cases. So when we look at the algorithms, there are many algorithms exist, but these algorithms can be broadly classified into two types. One is breadth first search algorithm. The next class is depth first search algorithm. So the classic algorithm for breadth first search is a priori algorithm, whereas for depth first search algorithms, the examples are ECLAT and FP growth. In the interest of time, we are not discussing these algorithms in detail. If users are interested, I request them to go through the web. Now, let's look at the part 2 of this presentation. That is introduction to our software, PAMI. So in this part 2 of our presentation, we will be discussing what is PAMI, what is the architecture of the PAMI, the installation, maintenance, and bug reporting. So PAMI stands for pattern mining. So it is the short form for this term, pattern mining. So we are distributing this open source Python library under GNU version 3 license. The source code of this PAMI software is available at my GitHub. The user manual is also available, followed by bugs and issues. So if you identify any bugs, please feel free to report them in the GitHub. Otherwise, you can also send an email to us at pami.report@gmail.com. So you can either post your comments in the issues or bugs, or you can send us an email and we will answer and respond to the email queries. So now we discuss about the origin of PAMI. The PAMI software, the motivation to develop PAMI software happened when I was working in Masaru Kishirigawa Sensei's lab at the University of Tokyo, Japan. So when I had this idea to develop the software PAMI, then I made some versions. I have implemented some algorithms and developed a version of PAMI. But the problem is the holistic perspection of developing the software was missed. I was writing the algorithms and I was simply putting them in the PAMI PyKit, so which is the old name. But the problem was each algorithm was like a separate island. There was no communication possible between the algorithms. When I found out that kind of gaps in between the algorithms, I tried to rewrite the entire package so that there can be communication between the programs. So the new PAMI I started developing after I joined as an associate professor at the University of Aizu, Japan. So I am thankful to the following people. So my supervisor, previous supervisor, Masaru Kishirigawa Sensei. Then my PhD supervisor, P. Krishna Reddy. Then another supervisor, Masashi Toyoda, Koji Jetsu, and my friend, Philip. So Philip is also a good friend and he's the one who developed SPMF. So most of my inspiration to develop PAMI came from him and his software. Now let's look at the architecture of PAMI. When you look at the architecture of the PAMI, the most important thing that we have to understand is the organization of the algorithms. How are the algorithms in the PAMI exist? So this was the most important challenge I faced when I was developing the new version of PAMI. So when I faced this problem, I came up with this hierarchical structure. So the first letter is going to be PAMI. The second level is going to be pattern model. The third level is going to be the type of the pattern. So basic means the basic model of a pattern, closed, maximal, and top. So these are the different versions for a pattern. And the last level is going to be the algorithms that exist. So this organizational structure is also shown here. Okay, so PAMI, the mathematical model, the type of the pattern, and different algorithms that exist. So this is what we are, how the algorithm. So if any user wants to use an algorithm from PAMI, they can simply say PAMI dot what kind of patterns the user is going to extract. Then whether the user wants all patterns or closed patterns, maximal patterns, top K patterns, and then he can choose the algorithm. So this is the process by which the user can import the libraries. Now let us look at the inputs and outputs of a PAMI algorithm. For any PAMI algorithm, you can input a database or a file as an input parameter, or you can also provide a data frame as an input. Sometimes the users wants to convert a data frame into a database file. To enable this functionality, we have provided a separate library called data frame to database. So this additional library can facilitate the users to input their data frame and get a database as an output. So the users can give a file or a data frame as an input, specify the algorithm specific constraints. Once given, then the output is going to be the interesting patterns. These patterns can be collected as a list, or you can save the patterns in a file, or if you want to read these patterns as a data frame, it is also possible. So data frame to data frame, so there is a consistency. This consistency we missed in the previous version, but we filled it now. And in the later presentations, we show how you can use data frame to database converter to convert a data frame into any database format. So this is the model. So input is a file, output are going to be patterns as a list, as a file, or a data frame. So once we know the inputs and outputs, next, let us understand how to install, maintain, and report bugs in the PAMI library. So these are the simple commands that user has to execute. Just users can say pip install PAMI to install the Python pattern mining repository. If you want to upgrade the PAMI library, please simply say pip install -- upgrade PAMI. If you want to uninstall the PAMI, then execute the command pip uninstall PAMI. If you want to see the details of our library, simply execute the command pip show PAMI. So these 4 commands will facilitate us in maintaining PAMI in the machine. So now let us look at a small demo on the installation procedure of PAMI. We use Jupyter to explain the installation and maintenance of PAMI. So simply click on the plus launcher and choose the terminal. So once you open the terminal, you will get this one. So here, please execute pip install PAMI. As you can see here, this command will install all the necessary libraries for the PAMI software. If you want to upgrade, okay, then you simply say pip install upgrade. Before executing, you can see that the version of the PAMI is provided here. 0.7, 0.9.7.3.4.24. Now, if you can upgrade, we have updated the PAMI. So you can see here from 0.24, we have upgraded our repository to 28. To find the details of the PAMI, simply type pip show PAMI and press the button, and you can find the version, the location where our packages are getting saved, and other details, the license and other information. So this is how we can. And if you want to remove the software, then simply say pip uninstall PAMI. Right. And our soft library will be uninstalled. And if you want to report any bugs or features that you need from our repository, please visit our GitHub page and mention them in the issues. And if anyone wants to use our algorithm, it is very simple. First, import our library, our algorithm using import command, and then pass the parameters to the algorithm. Simply say start mine. So this will start the mining process and extract all the patterns in the data. Once you have completed the mining process, you can read the patterns in the database. You can read the generated patterns as a data frame, or you can store them in the as a file or as a list. And memory runtime can also be calculated. This approach is more suitable for researchers who just want to find the patterns from the data. If anyone wants to evaluate our algorithms, then execution on the command line or the terminal is the best one. So in this case, simply use Python 3 and the location of the program, and you can pass on the parameters, that is input file, the output, the file in which we want to store the patterns, and the threshold value. And then our PAMI library will execute the corresponding algorithm and present the results. So this is advice for the researchers who want to evaluate their algorithm. For example, assume a particular researcher has developed a best algorithm and he wants to evaluate it against the available pattern mining algorithms. In that case, he can simply use this method too for evaluation purposes. Now, we look at the datasets. That is how to create datasets and the formats and so on. To understand these types of datasets, let's get into the types of datasets. When we look at the datasets, the type of a dataset or a database depends on the properties of its items. So the three main properties of an item are certainty, that is the probability of occurrence of an item, that is the certainty. Next one is type of value, that is whether the value is a binary value or a non-binary value. The next one is dimensionality, that is whether the dataset has temporal information, spatial information, or some other information. Next one is sometimes there is other forms of information available, that is hierarchy and multi-valued attributes. So we can So let us look at these types: certainty, type of value, dimensionality, and others. So when we classify the items based on the certainty of the values, we have certain items, that is the items that occur at 100% certainty, and we have uncertain items, that is items occurring with a probability that can vary from 0% to 100%. So an example of a certain item is, the best example is supermarket sales data. For example, assume there are three customers: customer one, customer two, and customer three. If the customer one has purchased bread, jam, and butter, we simply say it as bread, jam, and butter. Similarly, the customer two has purchased bread and butter. Customer three has purchased books and pencils. So this kind of data is called certain data. You can also think of keywords in a document or hashtags in feeds as certain data. Similarly, we have uncertain data also. For example, the object identification in images is a classic example for creating uncertain data sets. For example, look at the figure. So in this figure, the instance segmentation algorithm, say for instance, ResNet, has identified each person with some probability, and person, car, and buses with some probabilities. So once we have this kind of an information, then we call it uncertain items. Similarly, items, depending upon their values, they can be classified into two types: binary items and non-binary or utility items. Binary items take the value between 0 or 1. They can take only 0 or 1. Non-binary items can take values from minus infinity to plus infinity. So this is another one. So items are certain or uncertain. Each of these certain and uncertain can be further divided into binary or non-binary items. So in this case, if you see, okay, the supermarket sales data, we can see that the sales data can be represented in binary format. So 0, 1, 0. So bread, jam, butter, books, and pencils. So these are the items in a supermarket. The first customer has purchased bread, jam, and butter. So it is bread is 1, jam is 1, butter is 1. But books and pencils he did not purchase. So we said 0 for books, 0 for pencils. Similarly, we do it for customer 2 and the customer 3. So this example represents binary items. Now, if we look at non-binary items or utility items, we can say that customer 1 has purchased 3 packets of bread, 1 jar of jam, 2 pieces of butter. So when we create a data set in this format, okay, then we call this data set as utility data set or non-binary data. Similar example of in the image recognition also, we have objects: car, people, car, bus, people, and pets. We can say that at 9 o'clock photo, there are 2 cars that were identified. There is 1 bus, 6 people who have been identified, and there are 0 pets. So this kind of data sets we can produce. Next one is We can classify the items based on their dimensionality also. So one of the thing is frequency. So have only the frequency information. So I can use that to classify the items. Some items will have temporal information. Similarly, some items can have spatio-temporal information also. So these are the ways by which we can classify the items. For example, if you look at the supermarket sales data, it contains only frequency information. There is no time information nor spatial information. Now, if you look at the image recognition dataset, you can see that there is time information. So this dataset represents a temporal dataset because each image is associated with a timestamp. And when we done instance segmentation of this image, the resulting transactions are associated with the corresponding timestamp. Similarly, we have spatio-temporal dataset. For example, the figure on the left shows the global rainfall data, means at each pixel, how much amount of rainfall has fallen. So we have pixels and we have band. Band here is the time. Okay, so this kind of data we have. Similarly, this is the road network of Fukushima. And in these road segments, there are congestions. So we measure the congestion length. So that will also be represented here. So this kind of spatio-temporal data also exists. We discuss spatio-temporal data in the further slides. So this is it. Now let's look at the formats of databases. So when we are talking about the formats of a database, let us look at the types of items. We have said that items can be certain or uncertain. Items can be binary or utility or non-binary. Similarly, items can have frequency information, temporal information, and spatio-temporal information. So when we have items of these types, a database can be generated by performing many-to-many relationships between these sets. So we have certain binary transactional dataset, certain binary temporal database, certain binary spatio-temporal database. Similarly, we have uncertain binary transactional, uncertain binary temporal, uncertain binary spatio-temporal. Similarly, we have certain utility transactional and so on. So all these combinations are the forms in which we will be generating the data. The difficulty in handling the data sets is in handling certain data is relatively easy than handling uncertain data. Similarly, handling binary data is much easier than handling utility data set. Similarly, transactional database handling is much easier than handling temporal databases and is relatively easier than handling spatio-temporal datasets. So this is how the difficulty in handling the data arises. Now, when we look at the generalization, this is how it looks like. And then the difficulty. So when we start doing research and when we are trying to introduce a new type of patterns, we first start with the green line. Okay, so we assume data is certain, the items take binary, and then it is of transactional data set. So from there, we keep on increasing the difficulty in our research. And then we generally end when we try to handle uncertain data containing utility of the items in a spatio-temporal database. So this is how so whenever we propose a new type of pattern, we generally choose the data set much easier because your chances of getting publication gets increased. And then over a period of time, other researchers can extend this work to handle uncertain utility and spatio-temporal database. Now, let us look at the creation of transactional database. If we want to create transactional databases, we should know of these three rules. First, items within a transaction must be separated using a separator. So all items within a transaction must be separated. So the default separator we use in PAMI is tab space. However, users can use their own default separator, or they can override the default separator. The reason for using tab space as a default separator is due to the reason that some spatial items, especially line and polygon, use comma and space within themselves. So we cannot use line and space in handling spatial data sets. That's why we chose tab as the default space. So this is the format of a transactional database. So if you are creating a transactional database, simply say item 1 separator, item 2 separator, and so on up to item 1. So here we are using tab space as the default separator. Now, so this is the rule. Now, if you want to create a temporal database, in that case, the first column must represent a timestamp. It is called relative timestamp. The remaining columns in the transaction represent items. Timestamp and items must be separated with a separator. So default for ours is tab space. And most important one is timestamp of the first transaction must always be equal to 1. So this is how we have to create. So this is the format by which we have to. So we say the first timestamp is 1. Then there is a tab space followed by bread, jam, butter, separated by tab space. And please observe that the timestamp is relative rather than the absolute timestamps. Okay, because handling timestamps is much difficult in the real world. We moved from absolute timestamps to relative timestamps. If you give absolute timestamps, then our algorithm may produce incorrect results because it was not designed for absolute timestamps. And then next, when you are going to work on spatio-temporal datasets, the users have to give us two files. One is the neighborhood file and another one is the transactional or temporal database file. So the users have to give two forms of databases. So when you are giving the dataset as a neighborhood file, then what we have to do is neighbors must satisfy commutative property. So if B is neighbor of A, then A must also be a neighbor of B. So when we are specifying this list, we have to say A neighbor is B, C, and D, and so on. So this way we have to create a neighborhood file and we have to give. Don't worry, we have written the programs to generate neighborhood files. The user simply have to give a data set, and neighborhood file can be generated very easily using PAMI library. So here, so we have the rainfall data. So we have a pixel, and these are the band information. So bands are nothing but date on which the data is being collected. So we say 0, 0 pixel. These are the band information. Similarly, 0 0.1, 0, 1, 0, 2. So these are the pixels. Now what we do is we take this pixel information and we convert it into neighborhood information. So we say that for 0, 0 pixel, 0 0.1, 0 0.2, 0, 1, 0, 2, 1, 1. So these are the neighboring pixels for 0, 0. So we create this kind of information. Once we create this kind of information, we provide this information to the users and to the algorithm and generate whatever the necessary patterns exist. Next one is utility. So binary transactional databases are simple. Now, if we want to create an utility transactional database, the format is very simple. First, we have to specify items. Then we have to use the default marker followed by total utility and individual utility of its items. So let us assume that we have this information at the timestamp 000. Sensor 1 recorded 90, sensor 2 has recorded 10, sensor 3 has recorded 30. So once we have this kind of information, we simply say that in the first transaction, the recordings of S1, S2, and S3, the total value is 150, and the individual recordings are 90, 10, and 30. So this is how we will create an utility transactional database. Similarly, if we are creating a utility temporal database, we simply provide the timestamp information at the beginning. For spatiotemporal also the same thing. So we provide the neighborhood file one side and the utility transactional database as another file. And then if you want to create uncertain file, then this is the format. So we first mention the items followed by their uncertainty values. So this is how we keep creating the data set. Same thing. For temporal, we simply add the timestamp 1. Next one is converting data frames to database. So if you want to convert a data frame to databases, we have to understand that there are two types of data frames. One is a dense data frame. The other one is a sparse data frame. So both data frames can be provided as an input to our library, data frame to database, and you can expect our library to output to convert the data frames into transactional database and then temporal database. So simply user can input the data frame, can input their data frame to our library, which in turn will create a transactional database or a temporal database. So we will now look at the demo of this part. In this demo, we will now see how to convert a sparse data frame into a transactional database. So let us see the sparse data frame first. Cat sparse data frame.csv. So you can see that in this sparse data frame.csv file, the first column represents the transaction identifier. The second column represents the item. and the third column represents the value. So we have this data or CSV file. We will be reading this file as a data frame, and then we will be converting this CSV file or a data frame into a transactional database using PAMI. To do that, what you have to do is, first, please import the pandas package and then read the file. So the output is going to be a data frame. Okay, so we have read the CSV file here, and that file is stored as a data frame. Here we are simply printing the data frame. So this file and this file are the same. Okay, so now with the entire file has been read as a data frame. Now what we have to do is, we are converting this data frame into a temporal database format. So for that, what we have to do is, you have to call data frame to database. So first, please use the term from PAMI extras dot data frame to database, import data frame to database. So please import this program. Once you import this program, next create the object with data frame to database and pass the data frame. So next what we have to do is, we have to specify the threshold value. So in this case, we want to choose the values that are greater than or equivalent to 2. So any value whose threshold is greater than or equal to 2 will be chosen. Less than 2 values will be removed. And this is the condition. So by specifying these 3 parameters, what we do is, we execute the code. Once we execute the code, then what we do is, we simply save the file. So you can simply save the file. Sorry, so we have to do it from the beginning. So the file sample temporal.csv has been created and is stored. If you want, we can simply open the file. You can see that the first column represents the timestamp. The remaining columns represent the items. If we want to change the threshold value, we can simply change the threshold value and redo the, then we'll create a new file. You can see. So in this way, we can create a separate temporal file or a transactional data file, whichever we need. If we want, we can also use different formats. So if you say get database, so let us say this as so now we got one more file, transactional.tsv. So if you see here, this simply represents a transactional database. If you want temporal, we say temporal database. If we want a transactional database, we can simply mention it. If we want to create an utility database, here is the function. So specify the function utility database. So utility database.csv. So we have created the utility database. We can see here, we have created the utility database as well. So this way we can create any data set using our data frame to database. Here we have shown using sparse dataset. However, users can even use dense datasets to perform the same thing. So if we are using dense data set, please mention here database type. Here, the default type is sparse. This sparse means we are using sparse dataset. If the user is providing the dense dataset, then please mention here df type equal to dense. So if your input is a dense data frame, then please mention the type here. So this is how we can convert any file into any data frame into a transactional database, temporal database, and then utility database. Similarly, we will now show how to create transactional and temporal databases. So click on the text file. So if we want to create a transactional database, simply use the separator. You can use your own separator also. Otherwise, you can use tab space. So you can create the file and save it. If this is not the way you want to do it, then we can also use a terminal. So we can say vi transactional database dot tab separator file. So it is tsv. We can say a tab b c d. Next is b d. So we can create a transactional database in this format. If we want to create a temporal database, then we can say vi.temporal database dot tsv, then execute. So here for the temporal database, the first timestamp is going to be 1. Then tab. Please mention the items. Then our model allows irregular timestamps as well. So you can simply say 4. A, B. X. And so on. So we can create any format in this way, and we can input those data sets in our PAMI algorithm to find the patterns. We now end the session 1 and we open for questions. In the second session, we cover part 4, in which we will be looking at the database statistics, how to implement different algorithms, then how to integrate PAMI with other machine learning libraries to discover hidden knowledge in the database. So part 4 will be covered in the next session. So please ask your questions. Thank you very much for listening to our tutorial.